at it. So, okay. Um, Here again, day 23, right? Still about how many days? 77 days to go. Yeah. Okay. So, it's a long time coming. And a long way to go still. All right. Okay. My stream is on. And let's get at it. So, yesterday I learned, I spoke about sliding window for the very first time, which is an interesting technique in data structures and algorithm. So today um, I'm just going to solve some sliding window questions that I picked from LeetCode. I didn't even read them, so I'm not sure if I have what it takes to solve this question, but I'm pretty confident to do it. So at least a try is it's what a try, right? So let me just go ahead and revise quickly what a sliding window technique is. So a sliding window is basically an algorithm that you know that helps us look into a subset of an array and perform some operation. So it usually works on a contiguous block of data, where which also means that every item you have one item after the other. So a contiguous sequence of items. So it could be a substring of a string, which is, let me just say, a string called dad, right? This is a string, and a sliding window could have an operation on the first two characters, the second and the last, and so on, right? So it could be um you know a sub array, right? So an array of an array, we have the main array like this, 1 2 3, and then we want to maybe you know um take part of this array, any two elements in this array that will add up to, let's say, 3, right? So we can have 1 and 2, right, from this part to this part. Okay, so this will give us 1 2 like this, and when you sum this up, the answer will be 3. Okay, now that is not so everything yet, but another thing to understand about sliding window, the reason why it is called a sliding window, I will still use my example again, whereby we are given an array. I'll call this array x. X is equal to 1 2 and 3, let's say 6 and then 7, right? And we want to find two two items in this array such that they sum up to um what's the sum up to, I'll say 9, right? Would this work? So yeah, they sum up to 9, so I'll just use a k here. K is equal to 9. Now the sliding window um will you know sorry, I'll say they sum up to a target, so t is going to be equal to 9. T is going to be equal to 9, and k, which is our window, is going to be two items, right? A sub array, and the length of that sub array is going to be equal to 2. So we want two items in this array such that when we add those two items, we want to get a target which is 9, right? So, and I'll set k to be equal to 2. So my window is going to look like this. My window is going to target 2 items at a time. So I'll just do this like this, right? So now, why is it called a sliding window? After calculating the first sum here, right, we'll do 1 plus 2. 1 plus 2 is equal to 3, so it's not equal to 9 yet. So we'll slide the window across, right? We'll slide it across the array, and we want the ends of this window to point at 2 items in the array. So, which is what I'm doing here. So as I slid the window across to this side, the first end is pointing at 2, the second end is pointing at 3, right? So this 3 plus 2 is 5, so we've still not gotten our answer. So we'll slide the window again. We'll slide the window again to this point here. Now we'll have 3 and 6. So 3 plus 6 is going to be equal to 9, right? So this is our value, and we stop iterating at this point. We've gotten our targets, right? And I did an implementation of the sliding window, which is sorry. So this where is it again? So sliding window should be somewhere here. Okay. So this is my brute force solution, right? Although I will not say for sure this is a perfect brute force solution, but the idea of a brute force solution is for it to not be perfect, right? But yeah, this works, but we want something better, right? So sorry, this is not my brute force solution. This is the actual implementation. The brute force solution is this one. Is this one here, where we have an outer loop pointing at. So the outer loop will represent one end of the window, and the inner loop will represent another end. But this it's like, it's not really a sliding window. This is actually a two-pointer method of solving this question. But the sliding window technique is this one here, where we have the edges of the window representing each index, right? So we have we start from index I. Obviously I is going to be equal to 0, and then we'll only loop as much as as this point here. So this n here is the length of the array minus k, right? N minus k will stop somewhere here. So let's say the length of this array here is how many? 1, 2, 3, 4, 5, right? 5 minus k is equal to 2. 5 minus k is going to be equal to 3, which means our loop only has to run up to this point, right? So let's go again. This will be 0, 1, 2, and 3, right? So we have to stop here. And we know we have to stop here because our window is going to look something like this. In the last iteration, we are going to shift all the way here. We don't want to shift past this because the window will fall outside the array, and there is nothing outside, so that will be out of bounds. So we want to make sure that we are always within the array and within the range of k, right? Which is why we have to loop all the way to this point here, Okay, so if you want the code for this sliding window technique, I left a link in the description to the GitHub repo, so you can have that and work with it. Okay, so what's next? I think I should just quickly go through this implementation, this sliding window, once again to help solidify what I explained yesterday. So how does this method work? Now you can see we have a loop here, right? The loop goes all the way to the length of the array minus k. K is the length of the sub array that we need to use to find the maximum possible sum that we can get from the main array here, right? So k is going to be equal to 3 in this case. So we want 3 items, right? Such that when we add them together, we want the, the highest total that we can get, the highest possible total, right? So 3 items. In the first iteration, first of all, we found the total of the first 3 items, right? So this is going to be equal to 9, right? 9. So we first found 9, and what we did is we started with the first item here. We started from here. We still created the the um the window from the first item in the array, but then this operation here, right, this inner max here, is where we began to, slide the window across the array, right? So here's what we did, or here's what I did. So I started from this point, right? This window is here, right, at this point here, but this calculation here means the previous total that we got, right? So the previous total would have been 9 from this point all the way here. This would have been 9, but then I want to, slide the window across, which means I only need to shift the window away from this point and start from this point all the way to the third item again, right? Which also translates to the, the first item minus the the result we had before minus the total, and then we introduced a new item here, which is 2. So this calculation is doing that for us. So we are starting at index 1. In the first iteration, I would have been 0, right? And k is still equal to 3. So 0 plus 3 is 3, right? So 3 in this array will be 2, this 2 here, because at index 3, 2 is here, right? So we start counting from 0, 0, 1, 2, and then 3, right? So we added 3 item at position 3, which is 2, and then we removed what? We removed the first one. The first one would have been I, right? So we remove it from it. So in every iteration we begin, we slide the window towards the right. So we remove the previous item, right, or the starting point of the window previously, and then we introduce another item, which is where we shifted the window up to, right? And every time we need to find the maximum, since we are looking for the maximum number. So after computing this, we calculate it, we find the maximum between our latest calculation against our main value, right? And every time max sum is going to be replaced with a new value, which is awesome, right? And yeah, so the brute force solution is also similar, but yeah, I mean, it's not the most effective solution. So which is why we have the sliding window technique that helps it to be much more efficient and you know easier to implement as well. All right, so yeah, that's about it for the sliding window. Let me refresh again, and my bit rate is dropping really low. I don't know what's wrong with this network today. Not just today, my network has always been terrible. Okay, so what do we do next? Yeah, that's about it pretty much. Everything we need to know about sliding window, at least to get started, right? I'm still learning about sliding window, and that is, how I understood it. So let's try our hands on some question. So I actually came here, right? And in the description, I chose some question in certain order. Let me just go and verify again. So this first one would have been okay, so two contains duplicate 2, and then the second one is maximum maximum pair X or I. Hmm. Wow. Longest substring. Okay, so in that order, longest substring and repeated DNA. Okay. So again, I've not seen these questions before, so let me just try my hands on them using the sliding window technique for the first time. Okay. So, you can also look at the topics for each question, right? You can look at the topics and see what they are about. So this is about arrays, hash table, and sliding window. Okay, so let's go ahead and implement this. So it says it's an easy question, uh, but it has about 45.2% rate. No problem. Let's try it out. So given an integer array nums and an integer k, return true if there are two distinct indexes, right? I and j in the array such that nums at I is equal to nums at j, and then absolute value of I minus j is less or equal to k. Okay, let me let me read that again. Given an integer array nums and an integer k, return true if there are two distinct indexes I and j in the array such that nums at I is equal to nums at j, and then the absolute value of the difference between I and j is less or equal to k. Return true of for two. So we are looking for I and j, right? So yeah, this is good. Let me just come here to my board. I would erase everything here and bring this side. So all right, we've been given an array nums, right? And we want to find two um, two indexes or two items in this array at it says distinct indices, right? So distinct indices, um, such that when such that the values at that position is equal, right? And when we subtract them, right, their value is either going to be equal to 3 or going to be equal to k or less than k. Okay. Looking at this, we already see you know we can notice a pattern here, right? We can see like some form of solution here. So here's what I'm going to do, just like with human instinct, not just computer stuff, right? So I know, you know, let me just do, let me just subtract. So the condition says the two, wait, I at j has to be equal to I at, and nums at has to be equal to nums at j, and the absolute value of their difference has to be equal to k or less than k. Okay, so what two items do we see here that are equal? Well, this one here and this one are equal. Their index are obviously not the same, right? Let's say this is at index let's say index j, right? And okay, let's start with I. This at index I and this at index j, right? So these are obviously not equal. This is not equal to that. So we know this is going to be, I here is going to be 0, and I here, j here is going to be 1, 2, 3. So it's going to be 3, right? So that is good already. Let me just remove this and that. So we know this is I here is equal to 0, j here is equal to 3. And if we do 1 minus 1, this is going to be equal to 0. And we know 0 is less than 3. 0 is less than 3 here. Okay, so our value here is going to be, we are going to return true, right? Because there is a condition that, this operation actually satisfies the condition given in the problem. Okay, so how do we do this? How do we solve this question? How do we solve this question using a sliding window? Okay, using a sliding window, right? I'm just thinking, right? Well. We don't want the indexes to repeat, right? That's condition 1. We want the items at those separate indexes to be equal. Condition 2 and condition 3 is such that when we subtract the 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 duplicates that we found from each other, when we just find their difference should be equal to 3 to k or less than k. Okay. Okay. So how do we do this? Sliding window will slide only by a portion of items, right? So we start from here. We want 2 items. So let's say our window size is k, right? If we moved this from here, right, these two here are not equal, right? These two here are not equal. Automatically, it doesn't satisfy our operation. So we can then move the window to this point. These two again, they are not equal. This here, then the window ends, right? Which means we've not. This solution doesn't work. It won't work. So what do we do? Let me think. Let me think very well. We want distinct indexes, right? The distinct indices. And we also want the the difference between those items at the indexes to be, oh, sorry. uh Christ. Okay. We also want the items at those index to be, um the difference between those items to be less than k or equal to k. I mean, um Okay, so um imagine we take each item, right? Um okay, let's assume, right? Um let's assume that our window, right, is this small, right? It's just this small. So which means the both ends are on this point. I'll I'll put left and right, right? Not just to, um okay, let me just say my window is like this at this point here. And sliding window means I can, increase the window across, right? I can increase the window across and only move when a condition is not satisfactory. I mean, I can still keep it like this, right? Okay, so let's go back to the basics. Um, we want the items to have distinct indexes. Well, if the item is going to have distinct indexes, how about we create, um, we know maps will only have items of unique um, indexes, right? So, which means if we had a map here, let's say we had a map of each item, let's say one, then the next one is going to point at zero, and two is going to be at one, three is going to be at two, but we can't have one here again, right? This one here will not work because I mean it will just replace this, and yeah, so these are the unique items that we have. But well, okay, so how about we put each item in a map when we are iterating through the yeah, so when we are iterating through the array, right? These norms here, we add each item to the map, right? We add each item to the map, and then we we just run some calculation, right? We first of all check if the index of the map is not the same as the index of this iteration here, right? If it's not the same, then we want to perform a calculation, right? So we can do, let's say we are iterating through this array, right? If there's no item to the map in the map, let's add the item to the map, right? If the item is not in the map, let's add it to the map, and with its index. So first iteration, we are going to add I to the map, right? It's going to look something like this here. Sorry. We are going to add I here to the map, and at this point we can't run any computation, right? Or add I to the map, right? We add I to the map, and then subtract the next value from it, right? Or we do the difference between the two items. Okay, so the only condition where we will need to, you know, aha. So if we look to our right and the item here is the same as, you know, um, the previous one, then we know there's a chance that when we subtract the values, we'll get a value less or equal to k. Otherwise, if this doesn't satisfy that solution, that condition, we'll move the the window. We'll slide it like this. We'll slide it across. Let me just erase this. We'll slide the window across to this side. Now we'll add this item here to the window again, right? We'll add this item. We'll add this to the window, and then check the next value, right? If this the next value, we'll add this item to the map. Sorry, we'll add 2 to the map in the next iteration, and check, if the next value beside it is equal to is the same as that value, right? If it's not, then we'll just move it across. So in the first iteration, so in the second iteration, we want to add 2 to the map because 2 could possibly be in the array, so we are not sure yet, so we'll just keep it in the map. And then we look at the next value beside 2, right? If that value we added 2 to the map, right? We'll first of all check if 2 was already in the map, and I'm just thinking about this, so just bear with me. Let me see. uh okay, so okay, so we'll first add this value to the map, right? And then we will, after adding the value to the map, well, it's not needed, right? I mean, so we add the value at the ends of the distance to the map. So when we are at this point here, sorry, when we're at this point here, we would have moved the map here, and we'll compare. Nah, okay, so that doesn't work. How about we add each item to the map every time until we found a duplicate, right? When we find a duplicate, then it means, when we subtract those two values. Oh, okay. So we could actually loop through this array, right, and add each item to the map with, obviously their position, right? But if an item is already in the map, it means that's a duplicate. And when we subtract two values that are the same, we are sure to get 0, right? So, until we find a duplicate, we'll continue adding items to the map. And when we reach the end of the map, it means it's going to be equal to 0. I mean, it means we didn't see any duplicates. And yeah, I think that's it. So we loop through the array, right? We loop through the array each time, and we add, every item we see to the array, right? And to the map. Sorry, we add every item we see to the map, and then uh, we just keep an eye out for any duplicates. So if an item already exists in the map, then that is the item that that's at a different index, right? That's at a different index, And also when you subtract those two values, it's going to be equal to 0. I think that's it. So yeah, let me just come here. I'll implement that here. I'll call this, where is it? It's going to be part of sliding window. And what is it called? Contains duplicate 2. So contains nearby duplicate. Let's even look at the, wait, what if the values, the nums of length is there's going to be a num do, 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 do. 45.2 acceptance acceptance rate. This is okay. Then let me try it and see. So I'll just put it in the sliding window technique, and I'll call this contains duplicate 2, right? Contains, I'll call this dupe 2, dupe 2, right? And then I'll just come here, copy this, okay, and paste it here. So we need to import list. So list from list. So we import typing from. So we import list from typing. Sorry. All right. First of all, I'll create my map. I'll say distinct items map. This is a very long name. I'll just, you know what? Yeah, let's leave it like that. Okay, so the next thing is to iterate through the nums array, right? In for I in nums, and we want to in range of nums, range the length of the nums, right? We want to do this, and then we will first of all check if the item is not in the map, right? And then we add it to the map. So how do we do that? We know to add an item to the map, we just have to add, so distinct. So if nums at I not in the distinct map, if it's not in, then we want to add it. We want to add it to the map, so we want to do distinct map, right? So we don't want to do index, we want to do the actual value. So it's going to be nums at I is equal to Christ, my microphone is blocking my eyes. So this is going to be equal to I, right? So we are going to have the value against the index. Okay, so now if it already is, right, if it's already in the map, then we don't need to do something else. So we just say so if it's already in the map, we want to do we want to take that value. We want the actual value, not the index. Okay. Well, I mean, if we added this to the map, right? If we did something like this, distinct items map, at this, right? At I, right? This is either going to be any other value than, so this is not what we want to do. It's not going to be at I, but we want it to be at at norms I, right, where we found the duplicate. So, but this again, right, this is not going to return that value to us. It's going to return um it's going to return I mean, do we need to even calculate it? We already know if yeah, we don't need it. We don't need it at all. If we found a duplicate, right? If we found a duplicate, we just need to return true. We don't even need to compute this here again, because this here is not going to give us um it's not going to give us the value. Instead, it will give us it's not going to give us the key. We want the key of the map instead of the value, right? And yeah, so we don't need to even compute it. We know when we subtract those two values, it's going to give us 0, right? It's going to be 0. And 0, 0 has to be, wait, what's the condition again? Less or equal to k. So what if k is negative? What if k is negative? Right? What if k is negative and we have two negative values? So negative values, two negative values is going to be equal to the absolute. Wait, ABS. What does ABS do? ABS would change the value. Let me. Where's my playground? Playground here. So ABS prints ABS of -4, right? -4 is going to give us 4, which means if we had two negative values and we subtract them, right, like 2 minus 2, which will give us -4, then -4 is going to become 4 as an absolute value. It doesn't mean we have, the constant key. We found the key, so it means we still need to find the absolute value here. What do I do? So I'm thinking um I'm thinking, oh, somebody says so. Blurry face. Hi, welcome to the stream. It's nice to have you guys here. Honestly, makes me happy that we are all learning together. Okay, distinct items. Well, this is the case where we don't have ABS is going to return the absolute value, which is going to be equal to 0. So what do I do? I think that's the only part that is killing right now. Distinct items, I mean distinct indexes, equal items, um and an absolute value of their difference less or equal to k. Here we are able to create distinct items, right? In this case here, we are also able to find, this else here means we found an item that is already in this in this in this dictionary here, this map that we created. So how do we now take that value, right, and subtract them? If we know those two values, right, if we know those two values are equal, definitely we don't need to even get that value from the map here. We just need to make, I mean, this. So we can still do like, we can still do something like this. um we can still say, let's just cheat it. I say, if absolute, if abs of, you know uh nums nums at I, right, nums at I, which is the duplicate we found, minus nums at I again, nums at I, since it's the same value, right, since they are equal, so we know it's good, we can still repeat this again, right? If this is less or equal to what is it, equal to k, right, equal to k, then we can return true, we can return true, otherwise we return false, else we return false. I think, I mean, you might say this is like cheating my way through, but already we know that we found a duplicate, right? We found a duplicate, which is why we ended up here in the first place. So if we found a duplicate, it means those two values are the same. So we don't even need to go and retrieve that value from the dictionary itself, right? We can get the value here, and then the value twice. Just subtract that value by from itself, and then you know we'll get the absolute value and compare it to k, right? So let me just test some test cases here. I'll just use this. So we have nums equal to this array, and k is 3. So this should give us true. All right, so I'll create an instance of my solution class, solution equal to solution. Okay, and then let's print and see. So print solution dot contains duplicate. We want to provide this, and k is equal to 3. Sorry, 3. Right, let me just make sure that's correct. K is equal to 3, so we are expecting true as our answer. Let me close the terminal again and run the code. Yeah, this is true. So it works. It works. So let's use another case here. This is 1 2 3 and then 2. This should return false. This should be false. This should be false. So I'll just come here and do this, and this is going to be 2. Oh, now we have an issue. Now we have we have an issue. This is supposed to be false. Why is it returning true? Let me see. K is equal to 2, right? Wow, it says it's true. Wow, hold on. I'm saying if the absolute value here of nums at I minus nums at I. So let's say we added this, and this, right? Then we are at this point here. We found a duplicate. It's already in the array, right? I mean, if I print this thing here, at the end of the day, let me print the dictionary, so we see where our loop actually stopped at. Print dictionary, print our map. Sorry, I don't know why I'm calling it distinct map here. Let's print this and see what it looks like. Okay, so it's, wait, what? Hold on, something strange is happening. We have k is equal to 2. Why is the map not printing? Oh, because we already returned a value here. Okay, so let's say we print the map here. How about that? First iteration. So we'll have at least up to this point here. We'll have 3 items in the map before we get that value. Yeah, so we have up to 3, right? Oh, wait a minute. Hold on. K is equal to 2. And we want 2 items. Oh, less or equal to K. How is that possible? How less less or equal to K? I mean 0 is less than K. This is strange. This is very strange. So we have the question wants us to find two distinct indexes, right? I and j, such that the number at I is equal to the number at j, and the absolute value of their difference is going to be less or equal to k. So why am I getting? I mean, we have two items here, right, that are separate indexes. So this is going to be at, 0. This is going to be at index 2, right? This is going to be at index 2. And when we subtract this, it's less. Do we lead code? Christ. Are there any hints? No hints at all. Editorial. Locked. What is this? Is this, does it have to be equal to the value of k? How can, wait, why did this work in the first place? Is because the values we found are, 1 and 1. There's not even much explanation to this question. This is straight. Let me. Uh, oh, this is an easy question, by the way. Okay, so let's rethink this. Why is this even true? Why is this here true? Why is this true? It's true because we have 1 here, right? We have 0 here. We have 1 again here. So if 1 and 1 are the same, they are separate positions, and subtracting them will give you 0, which is less than k, right? Which is less than k, and you respect the less than equal to k. So a less than k, so which is true. So why is this not returning false? Why is this returning false in the first place? The constraint says k has to be, I mean, k can't be less than 0. Okay, k can be less than 0. I mean, which is what the absolute value is doing, right? The absolute value is basically transforming every negative value to positive value, and nums at I, right, can be negative and positive. or positive, the norms length has to be at least 1. Okay. Um, I'm not sure why this is false because we have two distinct items here, at least two items that are of the same value at distinct indexes, and you know the subtraction of these two is equal to 0. What's the absolute value of 0? The absolute value of 0 should be 0, right? It should be 0. So why is this not working? Uh, I mean, k being 2, right? Doesn't mean it's not. I mean, the result doesn't fall within the range of k. It has to be less or equal to k. Or is this a mistake? Wait. Yeah. This is strange. So we have 1 at position 0, 2 at position 1, 1 at position 0, 2 at position 1, 3 at position 2 here, right? And then we found 1 again, right? So we go ahead and find the day. So already we know that we found two values at separate indexes that are, you know, um, that are equal, right? Which is this first condition here. This first condition. This first condition here. Two distinct indexes. Yes. Or do I have to explicitly state where the indexes are? I don't need to do that. So, is there an issue with this? Let me check the discussion. I'm confused about this discussion. Why not say something along the line? Find two numbers in the array that are equal and at most k apart from each other, and are k apart from each other. Oh, you see, I read this wrong, right? So it's supposed to be the index, not the values. I was doing the values. So k at this point minus this, right? Oh, okay. So not this. It's going to be. Oh, yeah. So here we can get the index here, right? We can get the index here. Oh, my bad. Ah, absolute value of the value. So it's going to be distinct items map at this point. At this point here, right? This is going to be equal to 1 minus 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 I here. Minus I here, right? Let's see. This is false. Okay, this is false, which is correct. Um, why my mind? I was just reading the wrong thing all along. So I'll just try this out again. This other one. Let's just see if it works. I mean, we can just test directly in LeetCode, right? Because they don't mark the runs; they only mark the submissions. So I'll just come here. I think this solution will not work because I'm noticing something here. Because we found a duplicate and the values are not equal, doesn't mean there will not be any other duplicates where their indexes are going to. So here is returning false, right? This is not right. We need to go ahead and find every possible uh so which also means that, so here we need to allow the loop finish. We have to look for every possible value. Let's remove this for now. Right, we have to look for every possible combination that we can find. Yes. So we don't need to immediately return false. We don't need to do that. That is wrong. And we just have to move this here. Here. Alright, if we don't return true, then means we've not found anything, so we just return false. So I'll run this and see. Oh, there's a wrong answer. Oh wait. Okay, I left my print. So 1 is k. K is equal to 1. So which two items are equal such that it's going to be equal to this at 0. So we are here, right? So wait. Output is false and I return true. Why is that? Well, I see. Oh, so I'm returning. So I'm only adding. If it's not there, I'm adding it, right? And then when I found a duplicate, so what if the items are not there are still more pairs to look at, right? So let me just so here's what my solution is saying. So every time I don't see an item in the map, I add it to the map, right? um let me just erase this. I'll remove this from this part here. Wow, the time is, ah, god, why is time running so fast? I'll just increase my time to script. Let's increase to another 20 minutes. How about that? 20 minutes is okay. So my solution is saying that anytime I don't find a value in the map, right? So I'll just represent our map like this. I want to add the value here, right? I want to add 1 and its index 0, 2 and its index 0. I mean, 1 and 2, they are not the same, obviously. It's not a duplicate. So 3 and its index is equal to 0. But what about the case where I now found, a duplicate, right? This means that when I get a duplicate, I'll just, subtract their indexes, right? So this is at index 3, right? This is at index 3. So this I here, I in the iteration would have been 3, sorry. So 3, and 1 is at position 3, right? At I3, and the value of 1 here in the map is equal to 0. So if we do 0 minus 3, right? 0 minus 3. Wait, did I say? I mean, it doesn't really matter which one we subtract from the other, right? It doesn't really matter. So here, the absolute value of this, right? The absolute value of this is going to be equal to 3, right? Even though it's going to be negative. So the absolute value is 3. Now, what do we do with this? What do we do with this? We compare it to k, right? K is equal to 3. So this is correct in this case. So this is less or equal to k, right? Where k is also equal to 3. Now, imagine, we k was 4, right? Or let's say, yeah, k was yeah, let's say k was 4, and there is another one here, right? There's another one here like this. If we did this right, uh meaning, I mean, at this point here, let's say this is one. Okay, let me use this example here. It's going to be easier for me to do. I'll just take this example. Where is it? The second one here. K nums and k here. K is equal to 1. All right. Um, let's say k is equal to 1 here. So what do we do with this? I'm just going to come here. Again, we create our map. Our map is going to look something like this. So we have 1 at 0, 0 at 1. And then we found a duplicate. So what do we do in this case? We'll subtract the value, right? The duplicate from here, right? So 0, this will be our index 0, 1, and then 2, right? So this value here is going to be equal to 2. And we'll just do I, right? I, which is equal to 0, 0 minus 2. The absolute value of this is going to be equal to 2, right? Now 2 is superior to k. 2 is superior to k in this case. So this condition doesn't work. Now we know we are this condition doesn't work, and we'll then continue, right? We'll then continue to this point here. We have 3 here. But then if we, as we are increasing, right, as we are going towards the right, it means the index I will always increase. And no matter what we do, if we kept this here, right, if we kept this as 0, then we'll always not get a condition that satisfies k, right? That's, a calculation where k, the value, right, let me just put like result is going to be less or equal to k. So what we need to do here is, whenever we find a duplicate and we calculate we find the difference between those two items and their value is superior to k, then it means we need to change k I here, right? We need to change I here. Should I call this is not I, sorry. We need to change 1 here, right? The index of 1 here, we'll replace it with the current one. So I'll say 1 will be equal to 1. I'll replace 1 by, sorry, I'll replace the index of 1 with this one here, which is equal to 2. So if they are not equal, I'll not just continue checking, but I'll replace it with this one here, right? Which is equal to, I'll change it to 2. And then the next time I find a duplicate, which is 3, then I'll find the difference between those two indexes here. So it's going to be equal to 2 minus this position here, 3. This is going to be negative 3. Absolute value is 1. And we know k is equal to what? K is equal to 1. So here it satisfies this solution, this condition here. So 1 is less or equal to k. Yeah. I think that's what, so we need to reset our map every time we find a value that is larger than k. So how do we do that? If absolute value is less or equal to k, otherwise, right, else we don't just continue. Hold on. If the absolute value is superior to k, let's just look at that first. If it's superior to k, then we want to reset our map. So our distinct items map should look like this. We'll reset the value there. We'll change it to nums at I now, right? That will be the value is equal to I, right? And then in the case where it is not, we'll just return true. I think that's what we needed to do. So when I run this again, this is false as expected. So I'll just do that part here. I'll just put it in the code. Where is it? So distinct if absolute value, right? So we don't want to do it this way. So if this is superior to k, then we just say distinct distinct items map, right, at nums I. So we are setting a new map, right? Nums I should be equal to I now, right? So we'll change that index there. Otherwise, if it's not, um else just return true. Just return true. Okay, yeah. So let's run this again. This should pass all the test cases. Yeah, it has passed. Oh, let me remove my print statement here. It's not needed. So you can see we've actually passed this case. Let me run it again. All right, so I'll submit this and see what the solution is. Oh, okay. I mean, it passed it. I was even going to think about this year. I mean, this has passed. Congratulations. I was even going to think about here where we might have this here, right? We have just one item in the norms, right? We just have one item in the array, so we would not need to even check that here. I was going to put some edge cases here where norms is just equal to 1, so we just have one item in the array, and then if that value is not equal to r, then we just return false, right? So I'll just say okay, I mean, it works. What I meant by that is, let's say we have norms right, equal to just, let's say, 2, right? And oh, this will not work because we want two distinct items. Okay, that's fair. But lit code can be crazy sometimes. If this was a, I mean, between me and someone who set the question, I would have asked, and maybe they would have hinted that was actually possible. And yeah, so that is off the lists. I'm preparing an Excel sheet for all data structures and algorithm questions that I've been solving so far, and I'll provide this once I'm done creating the list. Maybe from now to up to Friday, I think. Yeah, between now and Friday, I should get this list ready, and I will begin to share it with you guys, to also use as well. Like, anyone who's looking to study data structures and algorithm. Okay, so let's see. Okay, I have 8 minutes left. Let me check the next question here. Okay, so we have another question. It's also an easy question. I'll just try and see if I can solve this quickly before the time runs out. So you are given a zero indexed integer array. I don't know why they try to complicate things like this. Zero indexed integer array means the index started from 0, right? And which is what we normally do. We always start counting from 0, right? Integer array norms. A pair of integers x and y is called a strong pair if it satisfies the condition um, x minus y is less or equal to minimum of the minimum between these two. X y. Okay, you need to select two integers from num such that they form a strong pair and they are bitwise. X or is the maximum among all strong pairs in the array. You need to select two integers from nums such that they form a strong pair and their bitwise is the maximum among all strong pairs in the array. Return the maximum XOR, which is the bitwise value, out of all possible strong pairs in the array. Note that you can pick the same integer twice to form a pair. So let's have a look at an example. We have 1, 2, 3, 4, and 5. There are 11 strong pairs in the okay. So we have 1 and 1, 1 and 2, 2 and 2, 2 and 3, 3 and 4, 3 and 3, 3 and 4, 3 and 5, 4 and 4. Oh, okay. Right. I think this is cool. So maximum XOR here is going to be, wait, how do you find XOR? The bitwise XOR Python. Wait, let me first of all think about the solution. Okay, so we have repeating numbers, right? And we also have one number after the other. So we are going 1 1 and then we are increasing 1 to this side and then 2 2 and then 2 3 3 3 3 4 4 4 5 5 4 5 then 5 5. Okay, so then we'll find the maximum XOR possible from these pairs. The maximum is 3 and 4. So is it 3 and 4 the absolute value of 3 and 4? This is not absolute. This is just, what is XOR operator? What is it? Let me check. I mean bitwise operator, right? The bitwise operators are used blah 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 blah. Okay, so this is XOR results bit 1 if any of the operand bit is not 1, but what the hell. Sorry. Hold on. I mean, getting this pairs here is not hard at all. I mean, we are going to just use a sliding window, right? And repeat those index each time in the iteration and then slide the window across, slide. But my problem here is the XOR here. I mean, how is it calculated? I don't know. I actually do not know right now. I have no idea. Oh, sorry. My solution that worked, I'll just bring it back to let me use my playground again. So my playground says what? Let me see. 2 and 1. Like this. What's the answer? It's 3. Okay. Okay, okay. 1 and 1 is going to be so we have the maximum possible pair from this is 3. So the maximum possible we could get is 3. Oh. So how is what's 4 and 4, right? What's 4 and 4? So this is the bitwise operator. 4 and 4. What's the- okay? Okay. All right. That is clear now. I think I can do this. Um. so, oh, I didn't know what. I mean, I've never used bitwise operators, right? I don't know what where we even need it. I mean, I've never run into any case like this. So we have these norms here, right? I want to find the maximum possible um, XOR value. Oh, I left out this. I need to copy everything. Norms. Okay, so norms is going to be equal to this. Right, we are here. So how do we create those pairs, right? In our first iteration, we need to do you know find the um oh so here's what we do. I'll just start from here, right? I'm at this position, right? This I in the first iteration. So let me just use a different color. So we have I here. I is at 0, right? I at 0 will be, so in our first iteration, I is equal to 0. Then we'll perform the first calculation. We'll do 1 1 1. We'll use 1. So in that we can see they are repeating indexes, right? So we can just do 1 1 and then 1, you know, with the next item, right? So first calculation, I'll just say max here is going to be equal to norms max is going to be equal to, so we are going to perform this calculation twice in every iteration. So we are going to do norms. Oh my god, why am I writing like an AI? norms norms here at 0, right? And then we find the bitwise operator here, and then norms at 0 again, norms at 0, norms at 0 again, right? We'll do this, we'll find the maximum and we'll compare it with, we'll have like a placeholder for the main maximum that we will possibly have. So I'll call this main, right? So first time we do this, right? First time we do this, we'll compare. um I mean, we can find the maximum straight away with the two operations. So I have a second one, which is the next item. So uh oh, I should have put I here. Anyway, it doesn't matter. We know we are in the first iteration. So I'll say max 2, right? Max 2. So in every iteration we want to calculate that. Max 2, I'll just put norms. My time is up. Norms at I again, and then we'll slide, like just this our window again. So norms at I plus norms 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 at I plus 1. Now this you have to put, like, we have to put a condition here for this operation to run, right? We have to put a condition there. Hey, this is not a plus. Oh. This is a bitwise operator, sorry. This is going to be, x and all, right? So we have to put a condition here such that if we're already at this position, right, we don't want to do plus one anymore. We don't want to compute this. We'll just go ahead and calculate. So after calculating this, our main max, right, our main max is going to be equal to, first of all, our main mass is going to be equal to the maximum between these two and the previous maximum we had before. So meaning we will compute the maximum twice again, right? So first of all find the maximum between these two, and we know we had previously stored the maximum here, right, which is our main maximum. We will then find that maximum again, because at the end of the day, this is the maximum we want to return, right? I'll just call this main maximum, right? Main main maximum. So we find the maximum between these two computation, and then we'll then find the maximum with between the current one and the one we previously got. So my time is up. I wish I could stay longer to to solve this, but I'll provide. I mean, you can check the GitHub link in the description to get all solved data structures and algorithm questions so far. Uh, yeah, this is this has been awesome. We'll continue tomorrow.